Argand plane or complex plane. What is Argand plane? When the xy plane is used for the purpose of displaying complex number set, geometrically it is called the complex plane or Argand plane. When the xy plane is used for the purpose of displaying complex number set. Okay, geometrically it is called the complex plane or Argand plane. Clear? Consider the complex number set is equal to x plus iy. Its representation in the Argand plane is ordered pair x comma y. X denotes the real part and y is the imaginary part. Okay, it can be represented in the Argand plane as ordered pair xy. Next, set a conjugate, that is x minus iy. X minus iy can be represented in the Argand plane as x comma, here the imaginary part is minus y, x comma minus y. Okay, x comma minus y. In the Argand plane, x-axis is known as real axis. X-axis is known as real axis and y-axis is known as imaginary axis. Imaginary axis. Okay. Next we are going to discuss how to represent complex numbers in Argand plane. How to represent complex numbers in Argand plane. Complex numbers are 2 plus 4i, 2 minus 4i, 0 minus I, 0 plus I, minus 2 minus 3i, minus 4 plus 3i. Okay. Corresponding ordered pairs of each numbers are, here it can be represented as ordered pair, first 2, then 4. Okay. The ordered pair of this is 2, 4. Next we can represent 2 minus 4i as 2 comma minus 4. Okay. 2 comma minus 4. Here the imaginary part is minus 4. Then we can write 2 minus 4. Next we represent 0 minus I. That is, here the real part is 0, imaginary part is minus 1. Minus I means minus 1 into I. Okay. Next we can represent it as, here the real part is 0, imaginary part is 1. 0, 1. It can be represented as, here the real part is minus 2, imaginary part is minus 3. Last one is, here the real part is minus 4, imaginary part is 3. Okay. We have to plot these numbers, these ordered pairs in xy plane. Okay. Now we can represent these ordered pairs in xy plane. Here the x-axis is the real axis and y-axis is the imaginary axis. Okay. Now first one is 2, 4. Here x is 2, y is 4. 2, 4. The point is here. Okay. 2, 4. Okay. Next we represent 2 minus 4. Here x is 2 and y is minus 4. We can represent here. Okay. That is 2 minus 4. Next we can represent 0 minus 1. X is 0, y is minus 1. That is, it be here. Okay. 0 minus 1. Okay. Next is 0, 1. That is 0, 1 be here. 0, 1. Okay. Next is minus 2, minus 3. That is minus 2 is x, minus 3 here. The point is here. Okay. Minus 2, minus 3. That is minus 2, minus 3. Next we represent minus 4, 3. That is minus 4 x here, 3 is here. Then the point be here. Minus 4, 3. Okay. Minus 4, 3. That is minus 4, 3. Okay. This is the representation of complex numbers in Argand plane. Okay. Next we are going to discuss representation of modulus of complex number. Set is equal to x plus iy in Argand plane. Representation of modulus of complex number. Set is equal to x plus iy in Argand plane. We know that modulus of a complex number z is equal to x plus iy is mod z is equal to root of x square plus y square. Okay. Modulus of complex number z is equal to x plus iy is the distance between xy and the origin 0, 0. First we draw the x-axis and y-axis. X-axis is the real axis and y-axis is the imaginary axis. Here the complex number z is equal to x plus iy can be represented as ordered pair xy. We can denote it as here, okay, x comma y. We give the name p. That means p of xy. This point is p of xy. And this distance, that is from origin 0, 0 to p of xy. This distance is known as modulus of a complex number. That can be represented as mod z. Okay. Representation of a complex number z is equal to x plus iy and its conjugate z conjugate is equal to x minus iy in the Argand plane. Here the complex number z is equal to x plus iy and its conjugate we can denote it as z conjugate is equal to x minus iy. Okay. The ordered pair of this is x comma y. Okay. The ordered pair of z conjugate is x comma minus y. Okay. Here the real axis xx dash and the imaginary axis yy dash and O the origin. Okay. First we represent ordered pair xy. Here x and y are positive number. Okay. So it can be represented in the first quadrant. That we can represent it as p of xy. Okay. That means we can represent OP like this. Okay. Next we represent ordered pair x comma minus y here. That is q of x comma minus y. Okay. Now we can represent q of x comma minus y like this. The point x comma minus y is the mirror image of the point x comma y in the real x-axis. Okay.